All right, everybody, here we go on number 12 on the Chapter 9 homework. Again, this is this idea of calculating beta, and so it's stuff we didn't really cover, and so I'm just kind of trying to work through it for you to help you through the process. So we'll start with a type 1 error can occur when a researcher concludes that the average hours of sleep changed, but the average hours of sleep did not change. And a type 2 error can occur when a researcher concludes that the average hours of sleep did not change, when in fact the average hours of sleep changed. All right, so now it tells us to calculate the probability of a type 2 error given the actual average hours of sleep is 508 minutes. So kind of like we had to do in 10 and 11, except those used a proportion. Here we're doing it just for a given value of a given mean, okay? So we have to, like always, start with what we know. So we'll start with our null, or that is the assumed or historical number here, which is 503 hours of sleep per night. We also know that our n, or our sample size, is 54. We also know our standard deviation, population standard deviation, is 63 minutes. And we know our alpha, 0.2. And we know our actual mean, population mean, is 508. So I'm just going to call this actual. And our actual is 508. That's given to us here in the problem. We're going to need our critical Z. So for this problem, we're looking at a two-tailed test right here, because what we're saying is to test if the average has changed recently. So this is like an equal to or not equal to kind of problem. So I'm going to say that this equals norm.s.inv of 1 minus alpha divided by 2, because it's a two-tailed test. So there's our critical Z. And now we're going to have to find our x bar alpha, which is our critical mean, or our trying to remember the exact name of it, but it's the critical sample mean. That's on page 412 in the textbook if you want it. I have it right here for you. So I'm going to call it x bar alpha, because that's how it's denotated, x bar alpha. And in this case, if you remember in the previous two problems, because it was a right-tailed test, we did the null plus these numbers. Here, because it's two-tailed, we've got to do both. We've got to do an upper and a lower. So I'm going to call this x bar alpha upper and x bar alpha lower. So to find the upper, this is going to equal our null plus our critical Z times our standard deviation divided by the square root of n. So this formula right here. And our x bar alpha lower is going to equal our null minus our critical Z times standard deviation divided by square root of n. All right. So once we find our x bar alpha upper and lower, now we have to find the z's of the actual given these points. So I'm just going to call it Z upper and Z lower. So that's this formula right here is the formula for the Z-score. So this is going to equal our X bar alpha, I'm doing for upper, so our X bar alpha upper minus our actual, that's what this little symbol stands for, our actual, divided by standard deviation, divided by the square root of n. And then we're going to do our Z lower, which is the X bar alpha lower minus the actual divided by standard deviation divided by the square root of n. Finally, we have to find the probability of something occurring between these 2 points. So what I'm going to do is I'm going to find the probability of the upper and then the probability of the lower. And then the difference between them will be the probability that it's between those 2 points. The probability of the upper is going to equal norm.s.dist, the upper z-score there, true. And the probability of the lower is going to equal norm.s.dist, the z-score of the lower, true. And the probability between will just be the probability of the upper minus the probability of the lower. There we go. And that is our beta, or our type 2 error. So 0.7264, no, 3 decimals, 0.726. Then it's going to ask us to calculate the probability of type 2 error given the actual average hours of sleep is 497. So I'm just going to change the actual to 497. Our calculator is good, so our new beta is 0.696. And there we go. Hopefully that was valuable to you. And if not, then we can talk about it the next time we see each other. Have a great weekend.